Fort Tejon, 1857. San Francisco, 1906. Loma Prieta, 1989. The San Andreas Fault is a scar that tells many stories, and every Californian has one. But for those who live on the lightning rod of earthquake country, the question remains, when the time comes for another large earthquake, will we be ready?
You know, scientists have been trying to predict earthquakes for over 100 years, and so far we've failed. The Earth just doesn't seem to give us signals that an earthquake's about to happen, and it's kind of surprising. We keep looking for those signals, we don't find them. So we have to resort to a more indirect means for forecasting earthquakes, and that is to build very complex models that put in everything we know about faults and previous earthquakes to try to get out the rate at which earthquakes might happen in a given region.
Researchers at the Southern California Earthquake Center, or SCEC, are seeking a better understanding of the complexities of earthquake phenomena. SCEC is devoted to developing this understanding, as well as effectively communicating it to both scientists and the public. SCEC's UseIT program is an information technology internship that improves SCEC's communicative capabilities by developing more advanced ways to visualize earthquake phenomena.
UseIT stands for Undergraduate Studies in Earthquake Information Technology, and I'm often asked by my friends what it's all about. And I like to describe it to people as doing big science, giving a very diverse and very talented group of students the opportunity to sort of work in this area and see what it's like. The big science piece that I usually talk about is that it's collaborative, it's multidisciplinary, and it's very information technology intensive. So the whole thing is that students have an opportunity to do this in an environment that's very intense, but they're also working very closely with scientists that are in the field, so they learn from the people that are actually doing the work.
So this year's Grand Challenge is centered around a forecasting model developed by scientists called USERF-3, which is the Uniform California Earthquake Rupture Forecast.
USERF-3 is an exciting new development in earthquake forecasting because it provides a new model about how ruptures can jump from fault to fault. This takes the previous set of only 7,000 potential ruptures and expands it to 200,000. This data set can now be communicated for the first time.
So what the interns are involved in with USERF-3 is to develop visualization capabilities involving software called SCEC Video and GIS to create earthquake rupture forecast sequences that would be suitable for public understanding as well as scientists.
So for the Grand Challenge, we had to integrate GIS into SCEC Video using different data sets. The data team found sets for fire stations, police stations, airports, California schools that could be used as safe havens in case of an emergency.
After the development team receives the data from the GIS team, we take this data and we create new plugins for SCEC Video. And a plugin is basically another tool that we create. And this tool is then used by the scripters to actually visualize the data.
So as the SCEC Video scripting team, we're kind of the last stop on all the information we've gotten from both the GIS data team and the programming coding team, and then finally us receiving it as the video scripting team and being able to take everything they've created and all of that data they've compiled and put into SCEC Video, and then creating videos that both the public and scientific community can use.
In order to gain some perspective on tackling this year's Grand Challenge, the interns took part in a field trip that spanned 2 days on the San Andreas Fault.
To see an end-to-end fault rupture, like to actually do it for 2 straight days, you really get a sense of, how big California is, how big this segment of the San Andreas Fault is, and how much real estate would move if that thing decides to move. So this is a 180-mile rupture, and it takes about almost 90 seconds for the Earth to unzip that distance. So to illustrate how dramatic that would be to the SCEC interns, we did over 2 days the entire rupture of the shakeout earthquake.
I was struck by an example several years ago when I was with a group of computer scientists on a field trip, and one of them said to me, well, I've never seen a fault before, but yet she'd been studying earth science for years. And we find that seeing something, seeing it up front and up close, is so important in the sense that it gives it a different kind of reality. And seeing it in nature actually gives you the opportunity to say, well, this is not really what it looks like in the book.
In addition to completing the Grand Challenge successfully, the interns' animations illustrating USURF3's data have already been put to scientific use. The group that developed USURF3, the Working Group on Earthquake Probabilities, has been able to use the interns' videos to visually present the scope of USURF3 to the California Earthquake Authority.
UseIT bridges the gap between the research world and where the rubber meets the road, so to speak. The broad audiences that are out there that are consuming the information in a lot of different ways. In particular for 2012 with the Uniform California Earthquake Rupture Forecast, is that you're taking all of this data from all these different sources, all these different people working together, and you slam it all together and you come up with something that's going to give people some useful information about how to be ready for the next earthquake.
In general, science education in this country has been geared at finding the few who are going to be scientists and sort of pushing aside the rest. So there's a fundamental issue that the more we get science and science principles out there with the general population, we're improving the ability of everybody to function in the modern world.